To gain the most from a multi-engine airplane, you must have a good understanding of its unique aerodynamics. Induced airflow is a good example. With wing-mounted engines, additional lift is produced from the induced airflow of the propeller slipstream. This is important to remember because a sudden power reduction results in an immediate loss of lift. This is very apparent on final approach just prior to touchdown. If you retard the throttles rapidly, the loss of lift may cause a high sink rate. Induced airflow is one reason you should carry some power throughout the approach and smoothly reduce it during the flare and touchdown. Two familiar aerodynamic terms, torque and P-factor, warrant special consideration for multi-engine flight. On some twin-engine aircraft, both propellers rotate clockwise when viewed from behind. This type of aircraft is often referred to as a conventional twin. With this type of aircraft, the torque produced by both propellers rotating in the same direction causes a greater rolling tendency to the left than in a single-engine airplane. P-factor is produced in the same way for twins as it is for single-engine airplanes, but its effects are greater. A left-turning tendency is created at high angles of attack when the descending propeller blade produces more thrust than the ascending blade. This asymmetrical propeller loading causes an even greater yawing tendency in a twin-engine airplane because there are now two descending propeller blades. Also, notice that the right engine exerts more of a yawing tendency than the left engine because its P-factor works farther from the center line of the aircraft. In a conventional twin, failure of the left engine would produce a greater turning tendency than failure of the right engine. This is the reason that the left engine is called the critical engine. Some twins have what are called counter-rotating propellers, where the right engine rotates in the opposite direction of the left. In this case, the airplane has no rolling tendency since the torque of each propeller cancels out the other. Also, there is no tendency to yaw to the left. P-factor is eliminated by placing the descending blade of each engine closest to the fuselage. In this case, neither engine is considered critical. With the engine inoperative, the lowest airspeed at which directional control can be maintained is called VMC. This speed, which is important to all wing-mounted multi-engine airplanes, will be covered in detail in the sections on engine-out aerodynamics and maneuvers. A solid foundation in multi-engine aerodynamics will enhance your transition to a twin.